All is quiet in Stacy Jones' 6th grade math class, though much is happening here. Her students, most of them avid self-starters, have learned how to use the first few minutes of class to focus on their assignments. And they know this time to prepare and catch up is brief.
2 minutes till we correct.
The tactic, allowing self-starters to get ahead and time for Mrs. Jones to quietly help those with questions, is a key element in a teaching practice known as explicit instruction. Achieving such efficiency and discipline in the classroom requires consistency from the teacher as well. These students tend to be focused because they know what is expected from them for each lesson. Instruction begins with a class recitation of the content and language objectives for the day.
Be able to identify angles as vertical, adjacent, complementary, or supplementary, and provide descriptions of each.
Next, Mrs. Jones does what all teachers do.
Put everything else away.
She tells students the information they need to achieve the class objectives.
Eyes up here. Let's try it. 2x, and then we added 4.
And in the teaching, she is careful to keep students engaged.
Plus 4 is? 8. It works for that one. Let's try this one. 3 times 2 is?
6.
Plus 4 is?
10.
That one works. The difference between telling and lecturing is I tell them what I expect them to know, and I want them to repeat it back to me. I tell them what we're going to do during the day, and they repeat it back to me. I have them finish my sentences so I know they're listening and understanding. I want them to repeat as a whole class so that even if they don't know, they can hear what the answer is.
Modeling, or carefully showing students how to work an assignment, is the core of instruction. Teaching is more than talking.
What do we need to find?
Common denominator.
Our denominators are 10 and 2.
The next step is to encourage students to move from mimicking to thinking, providing their own answers, perhaps with a little coaching.
Are 10 and 2 both prime? No, so we can't multiply them together. Can I count by 2 and say 10?
Yes.
Yes, so what is my denominator going to be?
10.
10.
Rote responses may help memorization, but application can be internalized by kinesthetic feedback. Stacy prompts the students to use their limbs to demonstrate geometry principles.
Okay, I need you to stand up, push your chair in, and face me. Can you see how that's a 90-degree angle? Yeah. Straight arm down, straight arm across. Show me 90 degrees with your arms. Straight arms. Straight up by your ear, straight out to the side. 90 degrees. What would we call this angle if we had 2 angles that equal 90 degrees?
Right.
What do we call them?
Complementary.
Complementary angles. Okay, if I was going to make a straight line with my arms would be out like this. What does a straight line equal?
180.
180 degrees. If I have 2 angles on a straight line, what is that called?
Supplementary.
Correct. Okay, show me 90 degrees. 2 angles that make up 90-degree angle are called what?
Complementary angles.
Show me a straight angle. 2 angles that make up a straight angle are called what?
Supplementary angles.
Correct.
Stacy has also found that a simple technology such as a whiteboard can encourage struggling students to try.
The whiteboard seems to be less intimidating for just paper and pencil. They seem to be able to write down what they know, and then they know they can erase it if it's incorrect. So they tend to put down what they think is correct, and then they can learn if they're wrong, and they can try again the next time. And 3, 2, 1, and show me. It looks like almost everyone has the correct answer.
In addition to whole class participation, smaller group work can help each student.
The advantage of working in groups is for children to learn from each other, where they can tell the group what they know, and maybe they know something different than someone else in their group, and they can add it to their problem solving. If a student can offer their information, what they know that maybe someone else doesn't, it boosts their self-esteem, makes them feel good about themselves, and that they can accomplish things in math.
Sooner than later, students must be allowed to produce their own answers. It is while they work on their assignments in class privately that the teacher can see what they know.
Independent practice is for me to know what they're understanding, how the class is doing, what we need to go over again, and the positive things that have come out of our lesson. So I have the students usually work on a worksheet, a review practice, while I'm helping a small group up in the front. I rotate the groups so that I can individually help the students and see what level they're at and what they're having a hard time with. The end product of explicit teaching is that the students enjoy math. They get to contribute what they know. They know what they're expected of for the lesson. They know the objectives. They'll see the same vocabulary words on testing. They know the vocabulary words. They've heard them, they've seen them, they've written them, they've said them. They feel confident in themselves. They feel like they can accomplish things in math. And they come away learning more because they're more confident.